welcome to our talk, Observability in the Wild. Thanks for your interest. My name is Florian L. I love everything about metrics, logs, and traces, and that's the reason why I do this presentation together with Josef. I'm a guest researcher at the university in Erlangen, and I'm working as a software engineer at QAware.
Yeah, and I'm Josef, and as software architect, I love cloud services, microservices, architectures, and often in a lot of projects, I'm a firefighter for performance problems, memory leaks, and so on. And yes, monitoring is my business. Yeah, and at home I'm dad, and at QAware I'm a technical manager of our business unit. This is our project and our product. We work for a German telco provider, and we are responsive for the cloud backend, for the architecture, infrastructure, and for the implementation of a lot of microservices. This product here is called Smart Speaker. It is a smart voice assistant like Alexa or Google Home product series. But today, the product is not in the focus. Today we want to talk about our observability ideas and the solution behind this, to operate this in a big cloud system. Our cloud infrastructure on the high-level approach is very, very, very easy. We have an OpenShift cluster. It's deployed on Azure Germany on the public cloud. We have microservices for Java in Spring Boot and Python. We have various services. We have a lot of services for voice interaction and text interaction, for the NLU and so on, and call a lot of functional skills, which are for weather, for radio, and so on. And we have a lot of backend components for our device, for our smart speaker, like the device management and so on. The current phase is a private beta phase within our project, and in this phase we have around about 70 microservices in production, and currently 120 microservices in our 4 staging and test environments, and scale up to 200, 300 pods in the production. No rocket science, but a lot of stuff for monitoring and operating. Our team is very, very heterogeneous. We have around about 50 developers and 50 persons in our project who are not developer, product managers, QA, and so on, not with a technical focus. We are a very colorful bunch of people with a different skill set. Young guys, older guys, and so on. We have 10 companies, around about 10 companies involved. Yeah, and it's not easy for one's cultural technical set. And this is why we want to talk today about collaborative monitoring, because we always knew that this is the truth. Observability is not just for operations. Everyone in an IT system can have benefits of that, of barriers, and we have to break down old barriers, we have to break down walls, we have to integrate it all together. Who of you is working in a project, in a product with DevOps processes? Only on paper or with? Only paper? No. No, okay, with DevOps processes. And what do you think, what is the hardest step in this cycle? What is your pain point in the last years? For us, it was the feedback. We have a lot of wonderful developers and testers, and we can deploy automatically, operate it wonderfully. We have a monitoring, and here was the gap. A lot of metrics, a lot of stuff, and no idea what is the real feedback. This is the learning, and we want to do it better in this project. Because 4 months ago I have seen this picture, and I think it's much better, because in this picture of the 6 C's of the DevOps cycle, it defines 2 important terms. Continuous testing, continuous release, continuous monitoring, and more important, collaborative development. Not only developer, all people in our project are in development teams. And collaborative feedback from our customer. And we build a platform. Our customer is not the smart speaker customer. Our customer is the skill developer or anything else. This is our customers, developers. Yeah. And why is this important? We want to show you this in our case study in the next slides, and yeah, take pictures and have fun.
Thank you so far. Now the case study, or how we found observability, collaborative monitoring in the mentioned real world project. So first I want to show you what is our monitoring toolchain. It's the open source cloud native standard. As Joseph said, we are running in Azure using OpenShift. Everything is packed in Docker containers. We use Spring and Python. And to analyze this application, we collect metrics, events, and traces. Metrics are collected with Prometheus and are analyzed in Grafana. And we also use the alerting mechanism of Grafana. We use Fluentd to collect the logs, store them in Elasticsearch, use Kibana. And we use tracing or plain Zipkin if you're using Zipkin or Spring Cloud Sluice if you're using Spring Boot services or Python services. So that's our monitoring toolchain. And generally speaking, one can split up monitoring in technical and functional. Of course, you can identify and model different layers of hardware monitoring, application monitoring, and so on, but I do not want to get into these details. Technical monitoring does not need knowledge about the application, while functional monitoring needs. So these are the basic concepts. So in technical monitoring, I want to answer questions like, are my services up and running? Do they accept traffic? And I ask, for example, the kube state exporter for metrics, or the node exporter from Prometheus, JMX, Top, IOSet, everything every tool that is around, and provide metrics for answering these questions. Functional monitoring, I want to understand my application. I want to see how long does my use cases took, what is the current amount of unique users, do I fulfill my service level agreements, are the service level agreements of third parties fulfilled, and yeah, of course, this is mostly specific instrumentation of the application. For analyzing this data, for example, you can use the use dashboard stands for utilization, saturation, and error rate. Is described by Brent and Greg. So we use this for memory, for CPU, and for typically for all the hardware resources. for example, or the red dashboard, we are using it for service runtimes. Red stands for request rate, error rate, and duration. It's described in a Weaveworks blog entry, and we found this very useful. And I know the conference is it's past 12:30. So, but if you have some time and you want to play around with this, both dashboards are in our booth in the main hall. So in our case studies, you can play around with it if you want to. So, but I know most of you already know this and do all the things correctly. But do you know collaborative monitoring? What could be collaborative monitoring be? Let me explain this with an example. So there was this little tiny shiny application that Joseph described, and there was the chatbot and the monitoring toolchain. And with the chatbot, I can ask the application for something. For example, as an ordinary user, I can ask the application to tell me a joke or ask for the weather forecast. So the chatbot is a natural interface where you can use natural language to interact with the application. So in our case, this is really useful because this is the typically process customer uses the product. So far so good. But what's missing is the integration into the monitoring toolchain. And therefore, we introduced this special flag verbose. And with this, the chatbot does not only print the response of the application, it also provides two links. One points to the zipkin trace and one points to the Kibana logs of this specific request. So, and we do this even in case of an error. So a user can simply understand what's happened and why the request was not successful. So if the user clicks on zipkin trace, jump into the zipkin UI, and you can see the total duration of the request. We can see which services are involved, and we have all the spans. And a user can simply click into a single span to see the details. So you can see the logs. A log is simply a timestamp and a message, a string message. Or you can see the text. So for example, you can see this was the text that was sent using the chatbot, how's the weather in Hamburg? And with this can understand how the application processes the request. But this is just standard zipkin features. One simply has to use it. To make this possible, we have to overcome our developers that want to implement functions and not tracing and so on. And to make this happen, we standardize tracing and metrics, so we get them a minimal piece of code to embed into the application, and the rest is working out. So for example, for tracing database calls, we implemented an annotation called trace database calls, and it is used for aspect-oriented programming. And in the aspect, we are measuring the execution time, and we have standardized time series names in Prometheus. So every database call is within a time series called database call duration and has two labels, the repository and the call. And this information is also written to the logs of a span. It's down there, and this was really, really useful, and we have lots of discussions with the developers that they want to not to implement or not to see any calls of trace.newSpan and so on, trace.newSpan. And we also standardized the tracing logs and the tags, as I mentioned. And the reason is that with span tags, one can search for traces. So for example, I can use the combination of the key and the value to search for traces of a specific user. And we use the span logs above to model database calls. Why? Because we want small traces. And you see in this example are 1, 2, 3, 4, 5 database calls. And this would lead, if we model every database call as a span, we have 5 more spans, which are really small and only took, so we only 1 millisecond because this is Redis, and thus do not add any more information. So, and for the spans, we also define some prefixes to identify our spans or to search for parameter values and so on. So this is just, again, oh, sorry, this was just to standardize, to make use from various sources to reuse queries and not to rewrite queries for every individual span. Was just to reduce work. And if you're going back and I click on the logs, it points me to our Kibana installation and with a predefined query. So I only want to see the logs for a specific trace ID. And again, I can see the involved services. And here is the application log. And I can understand how the application processes the request based on the logs. And this is really, really helpful. And the trace is the information that is written to every log message, and in this case is the context. And that's the reason why this is called contextual logging. But again, this is also just standard EFK stack plus contextual logging. And we achieve this by this small class. We're implementing a JSON provider for log4j. We defined our context, so it consists of the trace ID, the span ID, both from Zipkin, and the tenant and the user ID to identify the tenant and the user ID. And for every log event, we are reading out the map diagnostics context and check if the context is set. And if so, we write each context field as a single JSON field. So we use structured logging to reduce the processing overhead in FluentD. So, but we do not only use the chatbot for interacting with the application and asking requests and for the weather and so on. We also integrated health checks. So I can ask how is the cloud status for platform staging, and I see the trace, see the services, and I can see if they're up or down. So I can simply understand as an ordinary user, not the DevOps expert or the DevOps guy, I can see if everything is working. And also the end-to-end tests. So we can see the skill end-to-end tests are failing, and everything is linked with Prometheus. So let me show you this with a small video I've recorded. Okay. Wo ist es denn hin? Ah, okay. So this is the chatbot. This is the service list and show which servers are up and running. I can scroll down and I will see, oh, well, that's one test that fails. And I can click on the link and it opens the Grafana dashboard. So our end-to-end tests are executed continuously in a separate Docker container, runs Bug tests, write logs, and also expose Prometheus metrics. And there was, I guess this was too fast, there was a small link that points you to the test results. So I can see, or I can detect easily that there is a failing end-to-end test, and I can see in the logs which end-to-end test it was. So, for example, we are getting all the logs for this specific end-to-end test container. I can see that 175 tests are run, 1 failed, and above is the error message. So tenant should be handled independently. I have the run ID to identify the test run. And I see there's an error, and I also have the trace ID. I guess this could not be seen in the back. I have the trace ID, and with this trace ID, I can also jump into the logs of the application, and I can see the zipkin traces. So everything is linked with together to So, and with this, a developer can jump into his end-to-end test, understand what's happened, and yeah, of course, has most information to fix the bug. So, from a high-level perspective, this is our setup. We have lots of tests, infrastructure services that produce metrics. We are collecting them with the described toolchain, and we have the chatbot that reads the API and links into dashboards and predefined queries and so on. And we also want to integrate this in the first level support. So this the first level support get not a chatbot, get a specific customer care observability tool. And the idea is also to integrate all this information like the health checks or the end-to-end tests, the logs for a specific user, and the first level support can also activate tracing. So the idea is tracing is per default is deactivated. If a user calls, he can activate tracing for this user, and it's written to the token, to the access token, and every mobile app hardware device that is using this access token should start tracing if the tracing flag is true. And what's also a great point is that even in our tickets, the testers always write the trace ID and necessary information to reproduce bugs. And the developer just enters the trace ID to Zipkin or in Kibana and find the logs and the trace. So in the end, it's a happy end for the little tiny application and the monitoring toolchain. So
wonderful. And I hope you can hear me. Yeah. Okay. So it was like the technical things. Come back to summary and our lessons learned. Let's start with a recap, because indeed recap is an important tool in didactics I learned. Our recap here is collaborative monitoring. And our definition is monitoring for everyone. And everyone can use it, have benefits, without being an expert. And now you can take some pictures, because this is one important slide here with a summary. To make this happen, we have done 3 steps. We have conventions defined for our metrics, for our logs, for our traces, naming conventions, layouting, and so on, JSON style, and so on. Then we have a big data lake. All data come together, all environments, okay, prod separated, but all testing environments are in one data lake. And we link all the data smart together and integrate this smart data in tools, not in technical tools. We have integrated in everyday tools, in chatbot, perhaps next times in Excel, to open it and show traffic lights for managers. Perhaps, and this is the short summary. But perhaps one question from you. Have we create a uncontrollable observability monster? Overhead, memory overhead, runtime overhead, developer overhead. And yeah, one point, the lunch is not free. We have a complex architecture, a lot of services, a lot of microservices, and so we need a sophisticated monitoring solution, and there is nothing out of the box. No commercial tool, no open source tool for plug and play. You have to customize it for your project. But if you have this in your calculation, in your team as resource and in money, you can do it. And I think we have reached our main goal with this solution, because we have all tools integrated in one good tool set. We have easy integration found in a chatbot. It was very easy to give this to all members in our teams, and yeah, it makes fun. Everyone feels good after he had done error analysis themselves without an expert. We have QA testers with big eyes and write good tickets and say, oh, I have found your bug. Here is your ticket. Fix it. And we're not digging in the dark, and it's not cloudy. Yeah, it's very good in our project. And you can see it here. One learning is you can one metric is not a use case or can define the behavior of a system. There are always a lot of metrics. It depends on the use case or on the back end services you integrated. You have to know your system, find the right metrics for your dashboards, for your integration in the tools, and yeah, put them all together. So, lessons learned behind this all. The open source stack with the Fluent D and so on, and Prometheus and Zipkin and Sluice is very stable, bulletproofed. You can use it in production. It's well documented. It's easy to use. Yeah, it makes fun to use it. And we have more flexibility as in commercial products. But the effort to do it yourself and to maintain it and so on. But it's open source. You can make pull requests and so on and share this all together. One hard thing was on the first weeks, months, the mindset. Why should I use a chatbot and so on? But it was not long. It was okay, and the fun was there, and okay, there's a chatbot, and yeah, this was the acceptance was very fast in our project here in the brains. It was okay. Yeah, and the documentation is very easy with this tool stack. We have better error reports. We have auto-generated dependency trees in our Zipkin, and yeah, can copy this to our security or data engineers for see the complete whole thing and the mesh of all services together. Auto-generated with production load. Yeah, this is our lessons learned. And now, the real happy end. If you have questions, now or later in the next 1-2 hours on our QAware booth with the cloud coffer and nice colleagues. Okay. Other questions? I need the catchbox. Or no questions? Everything fine? Then, thank you for your time and come to our booth.